Hello, you are welcome. My name is Dr. Kingsley. In this class, I want to be taking us on very important topic, nomenclature of ethers. Nomenclature of ethers. Please do subscribe, like, and share my videos. Now, what are ethers? Now, ethers, they can also be called alkoxy-alkane. Alkoxy-alkane. Now, ethers are a class of organic compounds that have the general molecular formula RO R prime. That is their general molecular formula. R can be what? An alkyl group. R prime can also be an alkyl group. Can also be an alkyl group. Also, we have a situation for ethers where R is aryl group, is an aryl group, while R prime is also an aryl group. It is possible for ether. Remember, aryl group are groups that have what? That have that benzene, benzene ring. Then also it is possible for R to become an alkyl group while the R prime becomes what? Aryl group. It is also possible for us to have an ester. So in a nutshell, R and R prime can be alkyl group. It can be aryl group. It can be a mixture of either alkyl or aryl group. Now, if you look at the general molecular formula of ethers, you will find out that what? There is no hydrogen. So ethers, they don't have what? Free hydrogen. That is why they are what? They don't have high melting and boiling point. They have low melting and boiling point because there is no what? There is no hydrogen bonding in them. Now, let us look at the nomenclature of this class of compound, which is what? Which is ethers. Now, let R become CH3O, and this R will become what? CH3. You see that what? That this is methyl group and this is also methyl group. Now, this compound here, we see it as CH4, which is a methane. In which what? In which a alkoxy group is attached. Remember, alkoxy group is RO. So if we want to attach alkoxy group to this, one of the hydrogen will go, so that we'll have CH3, then we'll have O and what? And R. So you can see that what? That this compound is obtained from a methane. Methane loses one of the hydrogen, so that alkoxy group is attached to it. That is why if we want to name ethers, we name them as what? Alkoxy alkane. We name them as alkoxy alkane. So this is alkoxy group being attached to what? To an alkane, methane in this what? Case. Now, this compound is what? An alkoxy. Now, because we have alkoxy part of it and what? Alkane part of it, we can see that this alkoxy part is one carbon atom, which is methyl. So this is a methoxy. Then we have what? One carbon atom at the alkane part, which is what? Methane. So that is the name of the compound, methoxy methane. Now, because we have methyl group here and methyl group here, we can also call this compound dimethyl ether. Can call it dimethyl ether. Remember, dimethyl ether is a symmetrical ether. Why is it a symmetrical ether? When you take the oxo group here, we have methyl group and we have methyl. What we have here and what we have here are exactly the same. So that is why it is what? Symmetrical ether. Now if I have CH3, CH2, O, then CH2, Okay, CH3. Now, what will be the name of this compound? Now, we have this side, okay, and this side being of equal carbon atom. So this is also what? Symmetrical. It's also symmetrical ether. Now, what will be the name? Now, we name, if we want to name ether, how do we name ether? If we want to name ether, we name the alkoxy part first before we now name the alkane part. So we name alkoxy, we name alkane. Now, the alkoxy will be from here to where the oxygen is. And this is ethyl, then oxygen, that is ethoxy. Okay, ethoxy. That is from the word ethane, then oxygen, oxy. Then before we name the alkane part, the alkane having 2 carbon atom will be what? Ethane. So that is what? Ethoxy ethane. Remember, this can also be called diethyl ether. Why is it diethyl ether? Because here is ethyl, here is also what? Ethyl, 2 ethyls. So that is why diethyl ether. Now, if we want to continue our nomenclature, we might be meeting a case whereby the 2 alkyl groups are not the same. Let me say, for example, we have CH3, then O, CH2, CH3. Now, if you look at this compound, you see that the alkyl group here and the alkyl group here, they are not the same. Now, if they are not the same, which one will be the alkoxy part? Now, the rule is that what? The part having smaller number of carbon atom should be the alkoxy, while the one having larger carbon atom should be the alkane part. So that means this side have smaller carbon atom. That should be the alkoxy. So the oxy stops here. Okay, why this side become the what? The alkane part. Now, how do we name this alkoxy? This alkoxy have 1 carbon. That is what? Methoxy. From met and oxy, methoxy. Then this part which have larger carbon atom should be the alkane part. Alkane with what? 2 double carbons or 2 carbon atom is what? Is ethane. So this compound is what? Methoxy ethane. Don't name it ethoxy methane. No, not ethoxy methane, but methoxy what? Methoxy ethane. Because the alkoxy part must have what? The smaller carbon atom. Now, having understood this, we can also name this CH3, CH2, O, CH2, CH2, CH3. Okay? Which is the alkoxy. This one have what? 2 carbon. This one have what? 3 carbon. The one that have smaller carbon should be the alkoxy. So this is 2 carbon. That is what? Ethoxy. Okay? The larger carbon, which is 3, will now be the alkane, which is what? Propane. Propane in this what? In this case. So that is how to name. Now, we want to go to a situation now. A situation whereby we have something like CH3, O, CH2, CH2, CH3. Of course, we already know this part is the what? The alkane part, because it has what? Longer carbon. While this one with shorter carbon is the alkoxy part. Now, anytime the alkane part of these ethers are more than 2 carbon atom, we number. So we need to number this alkane part. But if you are numbering the alkane part, number it in such a way that what? That the oxo group is attached to the least what? Carbon. That is the number, the place where the oxo group will be attached. That is the oxy group. The place where it will be attached will be a part that have the least carbon, the least number in terms of numbering. That's what I mean. So if I want to number here, if I number here 1, 2, and 3, that means the ozo is what? Attached at number 3. But if I number from here 1, 2, and what? 3, that means the ozo is attached at number what? 1. So the one that will give the oxo the least possible number is accepted. So the ozo should be at number what? 1. So the alkoxy group is actually placed at carbon number 1. So that is why if you want to name this compound, it will be 1. You name the alkoxy, which is a methoxy. So that is 1 methoxy. Then we name what? Our propane. Alright, so that is it. Remember, this compound I have here is derived from what? From propane. Let's say you have propane, CH3, CH2, and what? And CH3. Then you want to attach alkoxy to it. In this case, our alkoxy is a CH3O. That is our alkoxy. Now we want to attach it to here. If we want to do that, one of the hydrogen atom here will leave, so that it becomes what? CH2. Then this will now what? Place itself, which is CH3. You can see that before you do what? Before you place this thing, you would have numbered the what? The propane. 1, 2, 3. So you are attaching the alkoxy at position number 1. That is why we say that what? Ethers are what? Alkanes, in which the name of the compound, okay, we start with the alkoxy part in our nomenclature. So that is a methoxy, okay. Then the methoxy is placed at carbon number 3. This methoxy is attached to carbon 3. So that is 3 methoxy. Okay. Then name the substituents. There is a methyl substituent at carbon number 3 and 4. That is 3,4-dimethyl. That is 3,4-dimethyl. Then name the entire system, which is okay, 5. All right, this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, 2 CH3 6. Remember, we are taking from here. So that is what? 3 ethoxy. Then the substituent are 3 and 4. That is 3,4-dimethyl. Then the entire longest chain is 6, which is what? Hexane. So with this, there is no substituent. But what we have here, we have substituents. Now, when we have 2 or more different substituents, if we are naming the substituent, we must name alphabetically. So that is to say, it's possible for us to have 2 or more substituents so that we can actually name alphabetically. Now let me take that situation. A situation where you have CH3O, then CH3, okay, CH3, then CHBr, then CH what? 3. Okay, we have methyl and bromo substituents. Now, from oxygen here is 1 carbon. From oxygen here is 1, 2, 3, 4, 5 carbon atoms. So this is the what? The alkoxy. Okay? Don't think that what? The alkoxy must always be this side. Don't think so. It depends on the what? The number of carbon here and here. In fact, let me do that here. I can do OCH what? 3. Then CH3, okay? CH, then you have CH3, then I have CH, okay, BR, then CH3, okay. Which one is the alkoxy? This part, after this O, this part, 1 carbon. Then from here, this side, how many carbons? We have 1, 2, 3, 4, 5, total of 5 carbon. So you can see that the alkoxy is this side because you have what? Smaller carbon. The alkoxy here, since it's 1 carbon, it is a methoxy. Methoxy. Now, if I number here 1, 2, 3, 4, the alkoxy will be placed at number 4. If I number from here 1, 2, this alkoxy will be placed at number 2. So I take smaller number, which is 1, 2, 3, 4, and what? And 5. So if I'm naming, I name the alkoxy first, indicating the position it is what placed. Remember the alkoxy from here till the oxygen. Where is it placed? As carbon number 2. So that is 2-methoxy. 2-methoxy. Then name the what? The substituent, but it must be alphabetical. We name B before met, M. So it's a 4-bromo. 4-bromo. Then you have what? 3-methyl. Methyl. What is the longest carbon? 5. 5 is what? Pentane. So the compound is a 2-methoxy, 4-bromo, 3-methyl pentane. All right. What of a case whereby you have an array group? Let's say we have this, an array group. Okay. Okay. This is an array group containing what? Benzene. Benzene ring. What will be the name? This is phenyl. This is phenyl. This is also what? Phenyl. Okay, when benzene is attached, it becomes what? Phenyl. How many phenyl? 2. So this is what? Diphenyl. Diphenyl. Okay? Ether. Diphenyl ether. Okay, that is the answer. Now, if you have enjoyed this class till now, why not subscribe? Okay, subscription will help you to promote this class and also help me, okay, or help you to know when actually that I'm putting forth my videos. Okay, so try to what? Subscribe to my channel, like and share my video, okay, for more lessons on chemistry, organic chemistry and others. Thank you very much.